Introduction to Python Pandas, Melt and Crosstab method. Today I'm going to use Jupyter Notebook as my IDE and feel free to use any IDE of your choice. As you know, the first statement for us is import pandas as PD as it would include all the important libraries in pandas which we can use it. Today I'm going to use a inline statement for HTML because we are going to work with a lot on data frames and displaying them. I feel it would be useful if we can format it in the style we need. So I have included this HTML formatting. The first statement for us is going to be how we can read a CSV and how we can go ahead and use the melt method on that. So this statement you should be very much comfortable by now. This will just read the CSV file and I'm going to parse the date function here and I have it here. And if you notice, we have three stocks: Amazon, Boeing, and Caterpillar. I chose it in such a way that they start with A, B, and C so that down the line it becomes very easy to discuss over it. And I am parsing the date because the file may contain the date in the string format, but I want to parse it so that it is in the data frame in the form of timestamp. Now that we have the information in the way we need it, we can go ahead and work with the melt function. Well, what is melt? I would say melt is opposite of converting to pivot. You have something in the pivot format, you can convert from pivot to a normal format. So here if you notice, I have this data frame 0, which is just a reflection of the CSV file. I read that CSV, that data frame, and I say my ID variable is date. That means I want in each of the row be identified by the date, and that is the ID I want to keep as is. But the remaining thing I want to convert into a melted form. If you execute this, you notice that you have the ID field date as is, and the variable is my header here. I have Amazon, Boeing, and Caterpillar, and my variable is Caterpillar here, and my values are the data in the body of the data frame. How come I have only Caterpillar? Is because I have put a filter constraint here. Here I am saying in my data frame where I want to check the variable, and if that is equal to Caterpillar for each and every row, that will return true, and then I want to display only those records in the data frame. So by this way I am putting a filter on each and every row, and I am making a decision which is the one I want to display. So let's say if I chose instead of Caterpillar Boeing, so here I say BA, and if I execute the same command again, then I would see BA. And one more thing to note is here the row ID is starting from 10. It's not because in the prior one we ended in 9, it's because the Boeing starts in ID 10. If I have cat, then I would have 20 because first 10 and the next 10 is taken away by Amazon and Boeing. Well, so now we were able to melt a pivot and we were able to convert that into a simple data format. But this is still not the way we want because I have the column header as variable values and those kind of stuff. So if you want to have a meaningful name, then we have two arguments to look out for. One is var name, which is a variable name which you can give a name as stock, and value name, which is the content or the data inside, and this we are talking about the stock closing market level, so I have named it as closing price or close price. And once again I have the same information here where I say I filter by by Amazon because that's the name of the variable I chose. So now if you run this statement, you can see you have 10 records with ID 0 to 9, and you see the dates and the closing level for them. So by this we were able to learn the concept of melt, how we can melt a pivot and convert into a simple data form. Now let's learn the concept of crosstab. Crosstab is also a very interesting concept, and in crosstab what is going to happen is if you have a data, you can slice it and dice it in the way you need. And this is very important for any data analysis process. So here, if you see, I have information regarding a wireless data, and here I have the name of the customers. So those are like Joy, John, Tom, Tim, and which carrier they are using for the phone lines. They may be through Verizon, they may be through T-Mobile, AT&T, Sprint, or any other service which they might have chosen. And they each of them can use the phone of their choice. Some may have iPhone, some may have LG, some may have Samsung or Moto, or whichever they chose. Coming to the plan, there are many different plans. So we have summarized this at a very high level, and we call the plan as metered and unlimited. So in the metered sense, a customer would have a meter that he is allowed so many minutes of voice, so many megabytes or gigabytes of data. Those are metered. That's because once he reaches that limit, then either he has to pay more or he has to choose some other plan based on his need. And the unlimited plan is you have a fixed price and you can use as much data as you want. So we assume we have only two plans which are metered and unlimited, but in reality there are hundreds of different plans within metered. Like there are 20 different levels or sizes, and within unlimited also there are different kinds. Okay, without going into that detail, now coming to the next column, tenure. Different people have been with the company for different period of time. So Joy has been with Verizon for 2 years. John has been with T-Mobile for 4 years. So different people have been a different number of years with the firm. And then the last column is the fees, that is their monthly fee or their anticipated fee or what they pay every month. In reality it would be little different every month, but let's leave it right there. So now let's try to analyze this data in the way the business needs it. Now the first step of crosstab is we want to see how many people are with a particular carrier and which phone are they using. Okay, now if I want to insert few more command line, I just press the B key and automatically it inserts few more command line. And then when I say panda.crosstab and I pass two parameter, one is DataFrame.carrier, a carrier, and DataFrame.phone. When I pass these two information, then it takes those two column and it tries to find the population who falls in which category. Maybe I can explain better after we execute this statement. Now if you see this statement, there is two customers from AT&T who use LG phone. Let's look here. AT&T one LG phone and AT&T one more LG phone. Perfect. And there are three customers from Verizon who are using Samsung phone. Let's look for that. So we have one Verizon, not this one. Yeah, Verizon, Samsung, one more Verizon, Samsung. Perfect. So by this we are able to count or find the frequency, or we can associate data point which will help us making statistical decision how many people are in which category or in which buckets. So we are able to group them in the way we need or in the way the business needs them. Now taking this a step further, let's look here. In this one, what I am doing is I am adding a extra parameter margin equal to true. So what does this margin equal to true does? It adds one row and one column to this output. So what's going to happen here is this row says cumulative value. So in AT&T, in total there are two customers. In T-Mobile, in total there are three customers. In metered plan, in total there are five, and unlimited is eight. So what does it mean? It means there are people are more inclined towards unlimited, and there are more people with Verizon. So it gives you a sense of the market, how the market is going, or what is the going trend. So you can sum them up and have a margin equal to true, and that will give you a sense of direction. Now, do we need to always have one level? In reality, we can have multi levels also. Let's look here. Always the first one is your X or your rows, and the second one is your column. So if you look here, let's look here. So this carrier is your rows, AT&T, Sprint, and all that stuff, and phone is your like LG, Moto, and all that kind of stuff. Coming to this statement, if you see, your rows once again is the carrier, AT&T, and all that, and your Y or your columns are metered and like unlimited, which is the plan. Now, since I want multi levels, what I'm going to do is I'm going to pass an array for the column, and for my rows I'm keeping as my phone carrier as is. So if I run this, I'm going to have two level. One level is going to be the phone, which is the level 0, and the second level is my plan. And let's see when I execute how this looks. Perfect. So this looks with two level. Okay, so one for the phone, which is this, one for the plan, that is this one. Then my carrier is here, like top to bottom every row, and I have all for in both columns and rows because I have set margin equal to true. So by this we can have multi-level analysis as well. Now that we have done multi-level analysis, let's go further and see what else we can do. So long what we have done is just counting. So like if you're familiar with SQL, this is like saying count, and a like aggregate function count based on certain rows and columns condition. But now instead of that, let's say we want to do some other logic. Now let's say I want to do a um, one sec. So we got this. Now let's do something else where we want to do a percentage calculation. So let's say we want to do a percentage calculation. So for every cell, then I can do something different. Now let's say index. So here what I am doing is I am passing my rows and column as phone carrier and the plan, and then I am saying normalize equal to index. So here I am saying normalization happens at a row level and margin is true. What does that mean? That means every row will will calculate the percentage on a scale of 100, and every row by itself is independent, and we calculate the percentage. So if you see AT&T, all 100% are in unlimited plan. If you see Sprint, 66% is on metered and 33% is on unlimited. T-Mobile is other way around, 33 on meter and unlimited 66. Verizon is 40-60 split. And then you add all the customer and you calculate the ratio of meter to unlimited. It's 0.38 and 0.61. So this particular table and this table has something in common, that they look the same. Here it's the whole value and here it's percentage. So look here, for AT&T you have unlimited 2 and all 2. When you divide 2 by 2 you get 100%, which is right here. And if you look at Verizon, you have 2 here and 3 here. You divide 3 by 5 and that gives you the 60%, which is right here. So these two tables are pretty similar. The only difference is here we are doing percentage calculation and there it's the whole frequency or the count. And now instead of index, let's say I switch to column and I execute the same command. Now if you notice, the whole row adds up to 1. So if you add all the metered customer, zero point 0.4, zero point 0.2, zero point 0.4, when you add up, it adds up to 1. And similarly, when you say unlimited, once again, when you add this, it adds up to 1. And maybe that's the reason they don't have one separate row in the bottom, because if you see that it will always add up to 1, then what's the point having one row in the bottom for all? So that's the reason they don't have a all in the bottom. This is the interesting one. So let's change it to all and let's execute this. Now if you notice, the way this has been built, always the total percentage is 100%. So whether you count by rows or you count by columns, so this one is 100%. Then you calculate the weight or you calculate the percentage on each of the firm, each of the phone carrier, AT&T how many customers, Sprint how many, and each of them in percentage you write here. So 15%, 23% you write here. And then you do in total how many people are in metered and unlimited, and then you break it down based on the weight. So that is something like this, but you calculate all rows and column, and when you do all, this is very interesting. Either ways you can do rows and column, and you can do the percentage calculation and it will give you the right results. Okay, that being said, let's do one more um, statement. This one is little different. Here we don't want to do percentage, we don't want to be doing simple count, but let's do something else. This time I'm going to do average or the mean. So that's the reason, if you see, when you do a crosstab, you pass the x parameter and y parameter, or you call the rows and the columns. After you are done that, you say your value is tenure. That means the customer has been with the firm for how many years. That is what you're going to have inside. And then whenever you have more than one customer, you would apply this aggregate function formula. Here it's going to be numpy mean. So that is the mean definition you have to apply there. And once you apply the mean definition there, it would do the mean calculation. And if you notice, wherever you don't have any customer, it will give NaN, not a number, because when you don't have a customer or a data point, you can't calculate its mean. So if you go back to, I think this one, if you see AT&T, except for LG, all of them is 0. And if you come down here, AT&T, except for LG, all of them are NaN. That is, we don't have any customer with the remaining phones, and that's the reason we have NaN. And the remaining all is a similar calculation. Wherever you don't have a data point, you would say NaN, and wherever you have a data point, you will say whatever is the average value will get displayed. And if you look into the documentation of Pandas, you would find in Crosstab there are a lot of like aggregate functions you can pass, and you can do a lot more fun stuff. With this, I am done for this video, and if you have any question, feel free to put it down in the comment section below. And if you like this video, please give me a thumbs up, and don't forget to subscribe to these videos, and also don't forget to click the bell button for future channel updates. Thank you, and you have a good day.